failure. And then even simple things like sensitivity of drifting larvae. If the larvae are drifting out and we get high storm events and we get these really high flows, could that result in increased mortality? You know, these are questions that just haven't been addressed in many cases, and so there's a lot to do. And then just to think, we've been thinking a lot about recruitment. So we've been thinking a lot about larvae, you know, recruiting into the system, but it's also about spawning. And we don't know a lot of those physiological changes in fish. We see often, for example, rainbow smelt. If they don't have a big early spring pulse, we'll see rainbow smelt not run into the rivers, and in fact, they seem, what's suggested is that they spawn on the shoals. How does that change their population, you know, dynamics? We're not sure. So there's a lot of interesting work that can be done in this region. Now, the final story is one of invasive species, and one that I think Lake Superior has been able to resist telling, besides sea lamprey, for some time. And this one is actually, I'm going to take you just to the outlet of Lake Superior, which is in the St. Mary's River, the connecting channel between Lake Superior and Lake Huron and Michigan. And in 2015, we got the notorious aquatic nuisance species called Didymosphenia geminata, or better known as rock snot. I think it has the best invasive species name ever. And, but, you know, I was just telling somebody this morning how we learned of it is we got a report that somebody thought there was a sewage overflow from Canada. And so when we got the material, I knew right away, they thought it was toilet paper. And you never want to be handling toilet paper out of the river. When I got it and I looked under the scope, right away I knew it was Didymo. It's these giant diatom cells that you can see under a dissecting scope. They're huge. But the problem is that they produce these huge stalks under certain conditions. And they bloom in oligotrophic conditions. So they're opposite of most algae in that they do well when nutrients are declining. So hopefully Lake Ontario doesn't see this with their pattern as well. But what we saw, we don't have great data really, surprisingly, to look at the outflow of Lake Superior. But the data from the state, they have a lot of no detections. Their analytical capabilities aren't great at low phosphorus levels. But what you do see is a trend of total phosphorus declining in the spring. And then this shows you the percentage of below detection values. So we are using this to kind of support the idea that samples are so low and they're more frequently low in recent years. And so this is supporting the idea that phosphorus could potentially be a driver. The strongest theory right now is that what's happening is this warming climate in Lake Superior is actually causing earlier spring thaws, and vegetation is holding on to phosphorus in the watershed for more, because it's growing earlier, so it's holding on to more phosphorus in the watershed instead of releasing it into the lake. If that's the case, we would expect to see these declining phosphorus levels. And those declining phosphorus levels are what are thought to trigger these blooms in Didymo. So we saw it first in the St. Mary's Rapid, which also happens to be a very important, very popular recreational wading fishery. This is where the stew locks are, right at the outflow of Lake Superior. But within a year, we saw it spread 30 kilometers down, and within 2 years, it spread 70 kilometers down. So any habitat that's like hard substrate, high flow, Didymo seems to grasp onto. So there's a question, it's debated about it being native or non-native, but I think its characteristics are truly that of an invasive, and at least what we're seeing. And the concern is that it grows in these really thick mats. It's called rock snot for a reason. It looks mucousy, but it actually feels like wet wool. And so if you think about, this is what it looks like covering the St. Mary's River Rapids, the really popular fishery. And so this is all cobble substrate, and it's somewhere between 5 and 10 centimeters thick, so these thick mats. And this is one of our most important recreational spawning habitats, so for recreational species like our salmonids. And so it's not, you don't have to be an ecologist to think about how that might impact the invertebrates, the drifting invertebrates that are an important food source for that system, and then the spawning fishes itself. And so we see that the overlap of when Didymo blooms at 2 of our sites really peaks in kind of late May, early June. And we've been working on some larval fish dynamics in the river for many years, and see that really when we get larval or fry emergence is right around here, starting late May, early June, and then lake sturgeon are a little bit later than that. So the peak in Didymo actually does overlap with some of our species that are recreationally and in terms of our native species that are important. So our next steps, we're doing a project this year looking at experimental manipulation where we'll be scrubbing Didymo from controlled areas and trying to understand, does it affect where salmonids spawn? Are they selecting for sites without Didymo? Are they selecting for, or are they not selecting at all? Are they just spawning wherever they can? And then we'll be looking at egg deposition and fry emergence in the spring to see whether or not that ultimately results in an impact to that population. So the fate of Didymo, I don't think is great. I think it's a sign that, it's what's predicted is that as the lake warms, that means that the lake, we're going to have more suitable habitat for invasive species. I think the St. Mary's River, the outflow is kind of the first signal of that. We're seeing that Didymo, since 2015, has bloomed every year. It's not on a cyclical dynamic. It wasn't just a low phosphorus year. So I think it's here. And I think we need to understand better what that means and what that means for the other lakes that are starting to see oligotrophication issues as well. Because it might not just be Lake Superior. This could certainly maybe spread to other regions. So I'll just wrap it up by saying, what is the final tale of Lake Superior? Certainly I don't know that. I think these are all areas that we need to be keeping an eye on, and we need more information in order to research. But I do think that there are kind of these extremes like we saw in Australia, where maybe they've passed the tipping point, that they've seen the signs for many decades, and now they're to the point where they're seeing these extreme fires and these extreme fish kills. I think Lake Superior hasn't gotten to that point. I think we're at the point where we still have the opportunity to get much more important information, needed data, where we can make informed decisions about how we manage those species, how we manage those habitats in order to resist some of the impacts of climate change. And then I will just end on one positive, and that is that Moerke cod are still in Australia, and this is my gratuitous fish picture, which is on my bucket list to catch a Moerke cod. So they have not all died, and that one didn't either. I put it back. So that's all I have. Any questions?